Welcome to NFD 24. For us, as said, very happy to be here for a second year continuously. And indeed, there has been changes and stuff which was added over the last year, myself included, joining the company. So my name is Ran Almog. I'm heading the product strategy for DriveNets. And with that, I'll take you through what Network Cloud is. These are the four topics, the four chapters that we will be discussing today. First off, an introduction of what Network Cloud is, in a way putting us all on the same page, explaining what does it mean when we are saying that we are building networks like cloud. It's kind of a big statement, and this needs some explanation, obviously. And then we will jump through into use cases. What is Network Cloud used for? What kind of network implementations can run on top of a Network Cloud? Or in another way of saying it, what kind of solutions are we solving? Moving through, the following session will be more about the architecture. This will be provided by Amir Tridon, our VP of Architecture. So if you have any nasty questions or tough technical questions, save it for him. And then we will conclude with an actual demonstration, and that's unique. Multiple routers running on the same infrastructure. This is going to be provided by our product manager, Eli Kosharovsky. He's going to be running a live demo with you guys. Very exciting, so stay tuned. There is a lot of good stuff coming, and we will start with building networks like cloud. A big statement, and what does it actually mean? When looking at a cloud, and we kind of try to boil it down from 20,000 feet high to three main pillars. First off, it's the lowest total cost of ownership of the network, just like a cloud has changed data center to make them more cost efficient. Secondly, it's optimal in terms of scaling. And when we're talking scaling, we're talking the scale of the hardware, which is not scaling up, but scaling out by definition. And we will see further down how this is translated. And of course, the scaling of the service itself. So the service is not limited to the boundaries of a single uniform hardware, but it can span beyond the a single device. And of course, taking these two items into one brings us to the value of cloud, which is the faster ability to innovate in terms of services. So cloud enables services to jump into our lives. Without cloud, they would not exist. Even Zoom that we are using now would not exist if not for the cloud. And obviously, nobody had Zoom in mind when cloud was perceived. So innovation is coming inherently with the thought of cloud. So this is what building networks like cloud means from a 20,000 feet high perspective. And next, we will be discussing more details. Now, who is DriveNets? Where are we coming from? And how come a small company from downtown Israel is coming up with this much of a claim? So we started off early 2016 with the idea of running a network function, which is traditionally a physical item, running it purely in software. And we went through into a full implementation of a router as the network function. And it was running to the level of production worthy, carrier grade, resilient, robust, rock solid, lots of protocols, lots of R&D investment was put into this. And it brought us to two things. One is obviously something which is already working and a lot of insights when it comes to this. And the second notion, perhaps more interesting, is the understanding that taking out the network function completely and decoupling it from the network is not necessarily a good thing. And the coupling to the network needs to be there still. And this is what led us to the idea or the thought of using white boxes, merchant silicon, wrapped up in a white box, and then this would be coming from an ODM because we are a software company, not a hardware company. So to cap up with this, we teamed up with a whole ecosystem of companies, the likes of ODMs, which are mentioned here on the slide, silicon providers, optical providers, all the components of what eventually consists of network cloud came into play. Of course, we are working towards opening everything towards this open standardization bodies. There has been contributions made into the OCP, TIP, in order to kind of open this ecosystem to as many players as possible, and of course keeping all the interfaces standard. And then perhaps at that point, this is when we started to accumulate a lot of attention from the media. Analysts, press are kind of all over the place in kind of cheering for us and acknowledging how interesting and exciting it is what we are doing. Lots of the rewards are mentioned here on the slide, just to kind of give perspective. These rewards cannot be bought. It's something that the media dictates on us and not something that we can dictate to the media, but not just the media. This is just one aspect and it's very important, but also actual customers, service providers identifying how interesting and exciting this is and how much of a potential this is for their long coveted transformation aspirations that they have been running for the last, I don't know, 10 or 15 years. Suddenly this comes up as something which can actually resolve these issues. So we've been having lots of engagements with service providers, and those are still ongoing. Of course, the highlighted one is AT&T, which is mentioned here as well. And the only one which we can talk about publicly as something which is in deployment, not the only one, but the only one we can talk about. And perhaps the wrapper to this is the funding round, which was mentioned earlier on. So we have coverage or understanding, acknowledgement from media and from our customers as to how exciting this is, and also this understanding from investors of how big of a potential this represents for networks in general and for obviously DriveNets specifically. So building a network like cloud starts from this. First off, this picture is real. This is a real live router, which is running here in our basement. And this is the biggest router in the world, active. This is also roughly the same size of a router, which is running AT&T. Okay, it's just the picture is actually from our lab because we cannot take pictures of the AT&T network. What we're talking about is disaggregation, and disaggregation has two folds from where DriveNets is standing. First off, it's the software, and then it's the hardware. We took the hardware and we broke it into its pieces, sub-pieces, and we took the software and we distributed it into being cloud native. This gave us the ability to run, of course, over a shared infrastructure, and that gave us scale. So we can scale from a single device running 4 terabit per second all the way up to a whole cluster, a factory or a class topology, it depends how you want to see it, of close to 700 terabit per second. Of course, with new generation of ASIC, this can span beyond terabit limits and reach petabits. The sky is the limit because there is no metal enclosure which is limiting us. This has been adopted obviously by AT&T, and this is kind of a well-known, but there are over 30 tier 1 service providers and operators in which we are already engaged in different levels of engagement. These engagements do take time. We acknowledge that, but we have these engagements in different stages running with, like stated here, over 30 different service providers worldwide. This is running from the US via Europe and throughout Asia. So this is really worldwide in its coverage. It boils down to these three terms, or these three attributes of what does it mean to run like a cloud. And I will take it from the bottom, from the hardware part, mainly because this is not our piece. We're running open platforms, white boxes, which are standardized and open, meaning that this piece can be contributed by any ODM or anybody who wants to step in and pitch into this discussion can make their own contribution. It's an open piece. It's just like cloud. Cloud took servers and what cloud is running, this is what's being done by hyperscalers, is using the same form factor of servers. Some even defined what kind of form factor servers they want into their data centers, the likes of what Facebook did with OCP. for example. The second pillar is about virtualization. We took the hardware as a resource, and in this case, what resource are we talking about is something that we will be discussing further down in this session. But by virtualizing it, we are enabling higher utilization of this network resource. So this tight coupling of the application to the hardware is no longer there, because the hardware is then abstracted to several instances by virtualization. This way, we can achieve a higher utilization of the hardware. Of course, the hardware is a very expensive resource. This is where you put your dollars into when you're building the network. And then third item is the software piece. And once again, this is not a monolithic, not network operating system. It's a network operating system which was built as a cloud native function. Microservice architecture built into containerized functions of the network operating system. And of course, as it's being cloud native, it can also run on several devices at the same time. So these are the three pillars that eventually consists of network cloud. And we will touch each and every one of these in more details further down in the session. Now, this should look familiar to you guys because it's been done before. We did not invent the wheel. We're just looking at something that worked really nicely, and in a way changed our lives. And we're in a way mimicking this. So we're looking at data centers or how they looked like 20 years ago. We had dedicated applications. Each application was running a dedicated machine. When you needed to add another service or another application, you needed to buy another machine. Not only buy another machine, but also configure this machine, this new server, into the peak potential performance of the application that you want to introduce, right? Because you cannot have it, failing the machine. So you configured your servers to the max. You utilize them on an average to roughly saying 10%, and this is coming from measurements. And then when you added redundancy, of course, you must add redundancy, then this 10% was even further dropped to 5%. And this is the average utilization of servers that you had in the traditional data centers. Obviously, bringing in a new service into the game meant more hardware. In many cases, that addition or how cumbersome adding another machine or another two machines into your data center is what prevented these services from even happening. So this is where we were, right? And then problems are the fact that we had lots of machines, lots of servers. We had lots of types of servers because every server was purposed for a dedicated application. And we had a lot of wasted resources as part of this, right? And this is what cloud has come and has been trying to resolve. So how did cloud do it? First off, using a standard hardware, one unified form factor that can run any type of an application, virtualization clearly, so that multiple applications can run on a unified machine, and taking the applications and making them cloud native so they can run above just a single machine. So when it comes to scaling the application, it's no longer scaling up, but scaling out. This is what cloud did. And what was the benefit? Clear. It saved a lot of cost. There are a lot fewer devices which are being placed into the fabric or the cluster of the cloud. Scaling is something which can be done elastically. It can the applications can grow and shrink. The infrastructure can grow and shrink, and these two are in a way decoupled one from the other. And of course, agility in introducing new services in a cloud formation. Introducing a service is just turning it on, right? And we are doing this on a continuous base throughout the industry. Everybody is dealing with innovation, is there already. We cannot even see our lives without the thought of cloud. This is cloud. And what we have seen is that networks today have the same types of challenges. Looking at the top layer of this slide, we're looking at a network sketch. And without disclosing my age, when I was in the university, this is how they taught me networking, by using this kind of a sketch. And indeed, this consists of lots of boxes, period, lots of box types as well. And each box type is in a way dedicated to serve a very specific application. So the result is that each and every one of these boxes is suffering from low utilization of its potential resources. And when it comes to resources, we will see further down what does it mean, and there is more than bandwidth to be discussed here. Scaling of any specific box is scaling up, because when you can kind of consist the size or the capacity of the device, you will need a new device, simply put, because you cannot scale out a chassis. And the outcome to this is that the network is essentially controlled by the vendors rather than the service operator. And that's a situation that service providers do not really like. Top or bottom layer of this slide is describing network cloud. And now network cloud is using two types of boxes to construct a fabric. This fabric, like I said, it's a fat tree topology, and the size of it is something which is done dynamically. And the type of function which is running is also dynamic. So any type of a function, network function, obviously, can run at any scale over this cluster and in any location within this cluster. That's the idea of making the network built like a cloud. And further down, we will see step by step how we broke it apart. Starting from the hardware side. And once again, because we're not a hardware company, what we are looking, the way that we are looking at the problem is interesting or innovative, I should say. The chassis has its basic elements. A line card, you're all familiar with this. The line card is interfacing the outside world. There is an ASIC inside. We took this out and we built it into one unified standalone machine. We call it NCP. It's a packet forwarder. This is what you see here, these boxes, the dark blue. The next one we're using is the backplane. There is a backplane connecting between the line cards and the fabric of the chassis. And what you see here are these cabling. That's optical cabling connecting the NCP to the fabric boxes. The fabric boxes, the blue ones, are actually the fabric engines, which we took out of the chassis and again built them into a dedicated standalone machine. You can see the actual boxes here on the right side of the slide. We call these NCP and NCF. We're going to be using these expressions further down in the presentation. And then we had the routing engines, usually running on control cards in the chassis. We took these and we just wrapped them up into standalone, standard, off-the-shelf x86 devices. And this is what's running the routing engine. Of course, our basic software is running on top of this. And obviously, this monolithic chassis is running some sort of an application. I don't know, maybe it's a core router as an instance. Maybe it's an edge router as an instance. We don't know, but on the network cloud aspect of things, again, there is an application running over this cluster, over this pod of connected devices, but not just one. Multiple applications can run on the same pod, and perhaps this is the major difference here between what a chassis is and what network cloud is. What's interesting to note is there is one thing that we didn't take from the chassis, and that's the chassis itself. That metal enclosure, which is in fact limiting what the chassis can do, or how big can it be, or how advanced what kind of advancement can it provide into a network which is evolving over time. The limitation is coming from the enclosure. This is what's limiting how much power will be pushed into this, how much cooling can be pushed out, or how much heat can be dissipated from the device is limited by the metal enclosure. And this is what we left out of the equation. Instead of that, we're using a software enclosure. We call it DNOR, our DriveNets orchestrator. You see an image of DNOR here on the top right corner of this slide. DNOR orchestrates everything in the cluster from the level of the very basic component and all the way up to looking at the entire cluster as one unified element or network element interconnecting with other elements in the network in any standard manner, like routing protocols and so on. So this is what DNOR is doing. And of course, each and every one of these services or functions that we have running are also managed by DNOR as a single pane of glass that gives the user full perspective of everything that is happening in the network. And then in terms of size, as already noted, we can start as low as a standalone device that can run everything on it, on a 2U machine, and then build any size of a cluster. The sizes that you see here are just examples. It doesn't need to be 16 tera, or there are any point between 16 tera and 96 tera, or 96 to 192. Any point in between is valid. Just build what kind of size cluster that you need. And of course, you can also scale your cluster as you go along. It's just more boxes and more connectivity in between them. So it's very, very flexible and elastic in what kind of structures can you consist. And moving forward, there's a 691 tera. This is with existing equipment. Moving further, it can go beyond. It can go petabit per second scale. We have the architecture to take us to about 3 terabit per petabit per second. We just didn't put it here because essentially we want to put here something which is already existing and not something which is planned. That's the hardware part of things. The second is the software part of things. And in this case, we took the thought of a monolithic network operating system and we tossed it away. And we built a network operating system which is modular. And not just modular, but distributed over several elements. This is where cloud native comes into play. So as noted, we're using microservice architecture. Functions within the operating system are built into containers. Each container can run anywhere in the network, and this gives us the ability to scale hardware as a standalone, as we have seen in the previous slide, and software as a result of being cloud native. We can grow each and every one of these services as a standalone. And of course, multiple services can then run over the cluster, and they do not interfere one with the other because there is a very clear allocation of resources by the fact that we took the hardware and we abstracted it and then virtualized it into segments. So we can attach a function, a network application, into the relevant resources which are consumed by this application. This is an important note which we will touch base on later on. More about the architecture behind this specific slide is going to come later in the presentation by Amir, who is going to be dedicated for the fabric side of things. So when we are talking disaggregation, there are 3 levels that we are talking about. Of course, the industry is talking disaggregation as something which separates hardware from software, and this is true. It's just that it's not everything. So separating hardware from software and then allowing the customer to patch it back together ends up with a router. That's not what what we're looking at. We're looking at establishing a platform that can run any type of a service. So we took the hardware, we broke it into its sub-pieces. We took the software, we broke it into its sub-pieces. This is what allowed us to disconnect the data plane from the control plane. And now each and every one of these can be scaled and consumed in a standalone manner. And this is what grants us that level of scalability that we have. And obviously the translation to this is better utilization of the hardware and of course the total cost of ownership of the network. So boiling it down to this TCO presentation or TCO slide, this graph came from ACG on a research that they did about network cloud versus traditional solutions. It's just one example, but throughout the report, you see that 50% point is reflected throughout. And there is more to TCO than just the cost of the hardware. What it says here that we're using or we are providing a lower cost white box, it's not that the white box is of a lower cost, it's actually a lower price, right? Because it's coming from a non-branded white box, it's not gathering any additional fees, or because it's not mounted with the software, what you're paying for is what you're getting, which is a box. And therefore, price is being structured by the ODM who is providing these boxes. That's not us, as a cost plus some kind of a margin of the ODM, as opposed to the traditional model in which you are paying for something which you're not really sure what you're getting. So not only that the hardware is being priced in a better way, we're enabling the better utilization of this hardware. Once again, we are a software company. Our motivation is that the maximum potential of the hardware is extracted, right? We are not in the business of selling a lot more hardware. We're in the business of making your spent dollars, or the max worth of the dollars that you spent on establishing your infrastructure, your physical infrastructure. Obviously, several use cases can be boiled into a single cluster, and therefore any type of connectivity that needed to connect between different routers are now embedded into the cluster. So the bottom line from this is that fewer ports are being consumed, fewer external ports actually need to be used in the formation of a network cloud versus a traditional model. And of course, the operational expenditure part is perhaps even more interesting. We will touch base on this in more details further down, but let's not ignore that fact that there is a lot of OpEx reduction here when going into more of an automated, modern, cloud-like infrastructure as opposed to the traditional aspect. So looking at these three pillars of cloud, establishing a lower cost topology, enabling scaling of the application and of the hardware, again, as two items which are standalone and each acting independently from the other. And one aspect which we did not really touch at this session, and we will touch in the next session, is about how easy it is to innovate, how fast it is to launch new services into this kind of an infrastructure. Just kind of recap. Building a network like a cloud means that the outcome, again, from the value perspective, is a network which costs less than a traditional network, maximizing the hardware which is being positioned in place, scales, in theory, indefinitely to the limitations of what ASIC technology or what ASIC radix is available. And of course, with new ASICs coming into play, it will scale more because there is no metal enclosure which is limiting it. And obviously, innovative. It's bringing innovation into play. Like I noted at the beginning, if not for cloud, a lot of the applications which we are using today would simply not exist. So once this is in place, innovation will follow, and it is already.
4 terabit is the smallest that you mentioned. Is that the lowest you can go? Because I mean, it's great for big ATT companies like that. They need quadrillion whatevers, right, to send to send a lot of data. But how about smaller companies that don't need quite that much?
Okay, great question. First off, I love the number quadrillion. I use it on a daily basis. No, we can do lower than this, obviously. And like I said, this describes the boxes which are currently in play, right? And there are certain boxes which are still in certain stages of development, and they are not developed here. They are developed with ODMs. So if an ODM is developing a device to go into a fronthaul gateway positioning with a capacity of 1 tera, once it's going to be available, it's going to be included within the boundaries of network cloud as well. The idea of using open standards and open standard interfaces between hardware and software is the fact that we can couple in any new hardware which supports these attributes, I'd say intuitively. It's not for free, right? But the effort invested into this is rather lightweight. So introducing smaller boxes into the portfolio is something which is in the making. But we didn't mention it here just because it's not kind of ready to face the market just yet. A few months, not more than a few months further out. Great question, though.
Your whole focus right now is service provider. I mean, you don't have anything for the enterprise at this time?
Well, yes and no. Yes, from the perspective of what we have shown today, no, from the perspective of how this should be then consumed, as a service, or consumed as a platform, or consumed as an infrastructure. So we're working with some service providers on how this is going to be reflected towards enterprises as a product off the shelf. I'd say not just yet. As a strategy, I'd say definitely so. Yeah.
Just real quick, and I think we'll get to it, so I can stand down. When we get to the architecture, are you guys going to discuss, around how you orchestrate or how you get into the weeds of the microservices within the distributed model? Obviously, I'm looking for, what is the orchestrator behind it? Will you guys get into that detail later on?
We will. We will. And you're going to hear it from the horse's mouth. So Amir is the guy that incepted the architecture. So you can really touch base with him on the details of how exactly this is working. And yes, this is going to be given in the next session.